Alrighty there. Good afternoon. It is Sunday the 14th of June, year of the change, 2020, and it's a hot one out here, folks. I'm going to try and speak up. I hope I got the sound set up right. I did everything I could to test it, make sure everything's hearing well in the audio. I did a test. My inverter is running the cooling fans pretty high because it is hot out. It is near 90. I did have the AC running, but I'm in a cloud at the moment, so I kicked off the AC, and I want to see if I can get this video done on my solar, talking about solar, and today's topic is charge controllers. I've been meaning to get this done for some time, but as many of you know, I've got some other things that are on the plate, but we're working towards it. We got a lot more videos to go, but for today, we're going to do a quick chat about charge controllers. So, let's start with this. The primary purpose of a charge controller is to have a device in between your solar panels and your batteries that regulates the amount of power going into it. And it's getting brighter out, as you can see. My face is lighting up, which means if it stays that way, I may kick on the AC. Maybe? Yes. Because it's hot, and I need to keep cool. And right now, my 1700 watts of solar on the pole out there is running 3 freezers and the AC and the computer and everything. So I've been doing pretty good until we got a little cloud pop up. So maybe let's see what we can do here. Kicking on low, medium. Yeah, it's probably going to be a little loud. I'm going to speak up so that hopefully you can hear me clearly. Sorry, this is the conditions that I have to work on, but we're talking about solar and living off grid, and I'm right in the midst of my stuff here. Maybe, rethinking it. Maybe I moved my desk somewhere else, but I like where I'm at. I like my system. So, let's talk charge controllers. The primary purpose is to protect your batteries because you can overcharge them. You can burn them up. You can put too much juice into them on an extended period of time, and all that does is serve to continue to create a chemical reaction within the batteries that exceeds what's necessary to make that battery fully charged. It's just that simple. Now, if you get that, then you know you got to have one, because you can't just throw a solar panel and wire it directly to your batteries without the potential for long-term issues. I've seen it done. I've done it for temporary, quick power. Hey, let's put some juice right into it. But when we're talking about designing and creating our system, one of the points that I've tried to make to you all is doing the math. Remember? We've talked about it quite a bit. Doing the math. Making sure that voltages match from one item to the next item, so that you don't overpower one item or another. It's all about matching your voltages, okay? And we've discussed this in the previous videos. So there's 2 basic kinds of charge controllers that you're concerned with. One, as what I'm going to refer to as a direct voltage charge controller. In other words, it does not change the voltage. It takes the voltage coming in from the solar panels and just monitors it going into the batteries. It doesn't convert the voltage from one voltage to another voltage. Make sense? So you have two kinds of charge controllers. One that goes direct. In other words, it takes a 24 volt panel and sends it directly into a 24 volt battery system. Real simple. Nothing hard and complex here. You keep that straight. Then you have the other side of it, which is the multi-power point tracking, MPPT, charge controllers. Those charge controllers are designed to take varying voltages, whatever might come in, and then reduce it to the voltage that you need for your battery bank. So if you have a 12 volt battery bank, it could take 66 volts and convert it down to 12 volts and up the ampage. So the amount of power going into your charge controller, that's an MPPT, might be a high voltage, like 90 or 100 or something like that, based on some of these large house panels like I've got on my pole mount, and only 9 amps, but it compresses it or converts it into a 24 volt voltage to go into my battery bank, so I'm not putting in too high a voltage, but it ups the ampage. So remember, volts times amps equals watts. So we're trying to take the wattage that's in the panels and put that volume, that amount of wattage, into our batteries. Make sense? So the MPPT technology that was put into our charge controllers is a very good thing, because it allows you to funnel a whole lot more in a way that gives you a lot of freeway in setting up your arrays. So that if you set up your arrays as to a voltage and ampage that is not to exceed the charge controller's capabilities, you can do a lot of different configurations. It really gives you some freedom. That's why we in the off-grid system like our charge controllers that are MPPT. So those are the basic understandings of what we want to look at and what we're doing. Again, it all boils down to matching your voltages. You want to make sure that what's coming from the solar panel is capable of going through the recommendations or the design settings for that charge controller, and then it outputs to the battery voltage that you need for your battery bank. That's the purpose. That's what we're doing. It is a controller, kind of like the government, right? Battery controller. All right, let's do a little looking around. And let's see, if I hit that button, it goes there, and then if I minimize that, then you can see this. So let's look across the board of different kinds, like I did with solar panels. We're going to do this with the charge controllers. And if you're just blindly looking for a charge controller, there's a lot of things out there that you can look at that will sound good, look good, and their price point's going to be really great. However, their quality of construction will leave you wanting. In other words, there's a whole lot of crap that has come out from China and other places that will technically and mathematically do the job, but when it comes down to it, the meat of your device is not thick enough. It's not enough. There's not enough real design into it. So, if I go into eBay and I do a search for solar charge controller, right? This is what I came up with. And we're going to scroll through here, look for some different things, talk about the options that they have, and discuss the quality and what our selections might be on different scenarios. So the very first one they throw up here is this nice little on a cell phone size. It's about this big, kind of they're broadcasting it. They're advertising it as MPPT, a 40 to 100 amp regulator charge controller for either a 12 or 24 volt autofocus tracking. Very good little price right here, right? 26 to 30 bucks. Well, here's my thoughts on this. These are the first ones. Here's another one right here. 12 to 24. If you're looking for a small system that is an RV where you're probably looking to do something under 500 watts. Did you hear me on that? Under 500 watts. You might get away with one of these cheapos. For a while. Maybe. I've seen this guy right here. These guys. I've seen these really, really cheap ones. This one is not a MPPT. This is a pulse width modulation dual USB charge regulator. This is a little different application. Okay? Let's not discuss this one as much because this is more of a direct. And we'll talk about directs. Directs are like the one that I showed you. I can't. It's kind of tangled up in here. My Sun Saver 10. It's a small one that's made by Morningstar. Those are, how should I say, a little bit better to find the cheaper ones, but when you get into MPPT, there's a reason why you probably don't want to buy one of these cheapos. We'll get into that in a minute. Alright, so here's a charge controller. I think this one kind of looks like the one that you see if you go into the Harbor Freight Tools. They got some small 10 amp, 20 amp, and 30 amp. Those are great for direct charge. They have options of either doing a 12 volt or 24 volt. They're not the highest quality because they're not the highest quality manufacturer, but you might get away with one of these cheapos in a small system where you've got a 12 volt panel and you want to charge a 12 volt battery system. They're probably going to work for a while. I wouldn't bet on them working for a very long time because of the quality of construction. Oh wait, look at what we have here. Xantrax. Xantrax is one of the companies that has been in the solar business for a very long time. They produce a variety of products on all the different size systems that we've talked about. This Xantrax C60 60 amp charge controller with the potential of handling a 12 or 24 volt wind generator, hydro and solar. So they've designed this. Now, the first thing I want you to notice about this, let's open this up in a new window here. Give it a chance to come up. Alright, so Hurricane Wind Power Turbine Technologies. Okay, there's no other pictures here. Let's take a quick look at that. You see this part right here? This is the part that's going to indicate to you that there was a whole lot more that went into the design of this particular electronic device than, and I'm going to close that, than these devices right here. You see that? What is that? Some of you may recognize that. That is a heat sink. My charge controller up here, and you've seen it in previous videos, has a huge aluminum cast heat sink. Why? Because they need to get the heat that is going to be generated by the friction and the resistance of the metals pulled up, because one of the long-term destructive powers of an electronic device is going to be the heating and cooling of the electronic components over time. Getting into it a little deeper. So this MPPT charge controller right here does not have protection for its internal electronic components. So if you maximize this and you took the maximum amount of solar power to go into it to the maximum amount of batteries that you could do it. And in other words, if you maximize this thing and you put it out on a sunny day like I've got right now, very powerful, bright sun and whatnot, you stand a chance of getting this thing pretty hot. One of the things that I've dealt with in all of the systems that I've built is you got to make sure that your wiring, like one of the very first videos we did was wiring and cabling, that your wiring is big enough not to be too much of a resistor and more of a conductor, so that the resistance there doesn't generate heat. So these things tend to wear out really quick because of the heat that's generated inside. And what happens is, solder joints and welds and stuff on the circuit boards, they tend to heat and shrink and heat and shrink and heat and shrink, and eventually you get stress cracks. You want to keep your equipment cool, and you want to know that you've got the sufficient amount of essentially wiring and metal. We all talk about precious metals, but copper is a precious metal. In my opinion, it's a monetary metal, but it's also a powerful metal. If you don't have enough of it, you got a problem within your machines. So a lot of people look at these and go, oh, I can get it. I can do the same thing that you're doing for $500 for $30. And they think they can get away with it. Wrong answer. So if you're going to do a direct voltage to voltage, 24 volt panel, which is nominally probably around 30 volts, to a 24 volt battery bank, which is going to be, varying charges based on the battery, you kind of want something like this, okay? Because you'll feel the weight of the difference. Now notice, you got $150 versus $30 or $40. You get what you pay for. Now, there's another MPT. So they've thrown up a bunch of them. Windy Nation, there's a little brand that's cheap. $24 for a 10 amp, 12 volts. So you're talking about 120 watts. That probably will be okay for a small system like that. But if you start getting bigger, let's see, Make Sky Blue Skies. This is a different one. I've never seen this brand. I'm not going to talk about them, but it looks like I got a cooling fan here. So what was I just saying about heat? If I got a little cooling fan here, maybe there's a little bit better engineering in it. You got a better price right here, a higher price. Not quite the same price as this brand, but a higher price. Let's see, what else can we look at? This one looks like, we got 12 volt, 5 amps. So this is just a tiny, tiny one. You're talking something small for a little radio system or even smaller. Renogy, there's a pretty good name. And you can even look at the quality of construction here. Now this is a MPPT charge controller. And I'm not sure how they got the heat sink set up in this, but it looks like there's a back panel. Let's click on this one just for the fun of it. Pull up this picture. I've never installed one of these, but let's take a look. It looks like it's a little bit better built. Has a LCD screen to give you the readings on the different functions, and it's got some lights. It's telling me it's probably a better quality made product. Something I might consider getting if I needed to. But it's still a smaller charge controller for most of your off-grid systems. So you got 12 and 24 volt, and up to 40 amps is what it's saying. We'd have to look at the specs. But let's go through here because I really want to get to some others. Oh, wait a second. Here we go. Outback. Outback is one of the companies out there that have been one of the top three. What I call the top three companies that produce off-grid solar products. So that Schneider, which is what I've got on the wall, Morningstar, and Outback. So if I'm ever going to recommend any kind of products, I'm generally going to go with those three. Okay? But here's a company that's got a MPPT 80 amp charge controller, and notice the price difference. Of course, you get what you pay for. But the ability to have a whole lot more power, and you notice the veininess. This thing's got it built into the system that it's designed to cool, because you got some grilling going on here. Does that make sense? It's like I'm losing sun. Turn that off for a little bit. So this particular brand, they're really trying to pump this one on eBay. Let's see what else we got. Oh, here we go. It's one of my favorites. So if you got a small system, this little 10 amp, 12 volt Sunsaver 10, that's the exact same one that I've got sitting right down here. This company has several varieties based on the size of the system that you might want for a small system. So, small radio systems, small water pump systems. You know, these are good charge controllers for those kinds of things. You know, my little battery bank, where you're not going to use huge amount of wattage over a daily period. But these are excellent. And like I said, you start searching for Morningstar, you're going to find 15s and 20 amps and higher voltages. But you got, this is your direct. These are your small system direct 12 volt panel, which is nominal 18 volts, to a 12 volt battery system, if that makes sense. Another Renogy one. These cheapos, boy, I don't know. Here's an Outback. They're pretty good. Different company. Let's go up here and let's change things. And let's just pull up all the Morningstars. Let's just see what's there for Morningstar charge controller. There you go. They've redone some of this. Is a new one. I haven't even looked at this one before, but this is a 15 amper. Here's a 10 amper again, and you can see they have different sizes. 6 amp, 12 volt. These are small ones. Oh, look, here we go. We've got a larger system. I put a couple of these size charge controllers into some small off-grid systems where we did some direct 24 volt systems to 24 volt battery banks of panels and stuff. You can see that the price point is not as bad, but it's higher than the others. And notice the massive grill on the front to help remove the heat. Very, very good. I own several of these Morningstars. Now this one is a direct. It is not an MPPT, but you can see the difference. And then we got some smaller ones. Another 10, 12. Here's a 45 amp, but this is a direct. This is not an MPPT, so 45 amp, which means it's going to handle. Let's go quick on it real quick. 176. It's going to be a little flatter. You'll notice the sides there. The thickness is not as the same because there's a whole lot less in the componentry, because you're not converting one voltage to another, which means transforming, which means a lot of copper wiring, which means a lot of heat. So this is a direct voltage to voltage deal there. So where were we going to go with that? Stella Volta. I just ordered some of our stuff for Steven, or from these guys, Stella Volta, just because it was a good price. 45. So they'll do a 12, 24, and a 48 volt battery bank. So this has the potential to do more than just one bank size. This is what we're talking about, sizing systems, you know. So let's see. Here we go. Here's an MPPT 60. But this is a used one. It's still the point. New ones are generally around $500, but let's open this one in a new window. And do we have a side view? No, it's just a back view. Alright, so it's hard to see it, but there's a very big grill. And yeah, the way they took the picture, you can't see the thickness. Alright, so I'll just show you with my fingers. The direct voltage, 24 to 24 volt kind of system, is only about this big. But these guys, what you're looking at, is about that thick. They're really thick, and they're heavy. You know, quite a weight to them, because of the amount of copper and the amount of, you know, cast aluminum for heat sink, because of the amount of work that it's got to do. Here's a 60 amp tri-star for 12, 24 volt. That's a good one, but you notice, like I said, they're thin. Oh, look, you see these guys right here? All right, you see them? Just to let you know, I've dealt with them, and I checked them out, and I will not order anything from them again. Just so you know, you may not want to, because they had gave out some very bad information. They supposedly had a NABSAP certified person there helping with the systems, and he did not know how to size cables. And he also did a drawing for a guy that I was trying to help, and on the drawing it was cross-wired on the battery banks, which I showed the guy I was doing the system for. Well, if you do this and you connect it, and I literally did it, and the spark, the electrical short, scared the shit out of him. I said, but so, oh, this is what he showed you. I said, do you agree where I'm connecting is where he's saying for you to connect? He said, yeah, he told me to do it wrong. Yeah. So you may not want to go to these guys. Just letting you know. Here's a direct voltage to voltage. Let's see. Here's the MPT. See, notice the price difference. Brand new, $600. And we're all in Morningstar. Let's see if there's a side here. See, here's a side view. You can see the thickness is much thicker. That means there's a lot more metal sitting right here. You know, you're getting what you pay for. Okay? So there are a variety of sizes of charge controllers based on your application. We're focusing on what is our input, matching that voltage to the charge controller's capabilities, and what the output is for the battery bank. Basically, you're going to have to balance those out, match those. It looks like I've got somebody coming back. Tia is coming back. I want to take one last look here. We're going to go to Schneider. And the, let's see, Connect 6150 MPPT. So this is the charge controller that's hanging on my wall. Okay? That's not the, you know, not the whole package, the inverter or anything. But this is the charge controller that I'm using. So I have in my stocks a couple of those Morningstars and one of these Schneider 60s. So 60 amp, 60 amp, 45 amp, and a couple of smaller ones. So I use a lot of these. This is quality equipment. You got Outback, Morningstar, and Schneider. Those are the three go-to companies. Now, there are some others that you can go to, but generally you get what you pay for. And if you're going to do an off-grid system, you generally want to have two components of that system maxed out for the highest quality. One is your charge controller and the other is in your inverter. Now we'll do the inverter video after we do the battery video. We're going to do the battery video next. But the inverter video, those two components, if you max those out, when you design your system, then that leaves you a lot of leeway to add more panels and add more batteries. Generally, those two are the next variable that you can play around with when you're sizing your system. But for the most part, I think that pretty much covers our discussion on charge controllers. And now that the sun's back out, I'm going to kick the AC back on, and that's fans running. So I hope you gained something for today, and we will catch you again soon. Y'all take care.